Hello everyone. This video is a continuation of fundamental concept on nucleophilic substitution reaction. In this video, I am going to discuss solvents for SN1 and SN2 reaction. We can classify the solvents into two types, polar solvent and non-polar solvent. Polar solvent again can be classified into polar protic solvent and polar aprotic solvent. I have already designed a video on the solvents, so the link of this video will be shared in the description box. Polar protic solvent is like water, ammonia, methanol, ethanol. These solvents have OH or NH bonds, and that's why they can participate in hydrogen bonding. Polar aprotic solvents have hydrogens, but these hydrogens are somewhere else. It's not with OH or NH, and that's why they cannot make hydrogen bonds with others. Like example of polar aprotic solvents are acetone, dimethyl formamide, dimethyl sulfoxide, acetonitrile. SN1 and SN2 reaction is dependent on solvent. First explore SN1 reaction and the solvent. My last two videos I have explained that in SN1 reaction, formation of stable carbocation is the crucial factor. And rate of the SN1 reaction depends on the concentration of substrate. It is independent on the concentration of the nucleophile. So in this reaction, this is substrate tertiary butyl chloride and water is a nucleophile. So when we use a polar protic solvent can make hydrogen bonds with this carbocation, and it gives the extra stability to the carbocation which facilitates SN1 reaction. That's why SN1 reaction favored in the polar protic solvent. So here we have taken one example. Tertiary butyl bromide reacts with water and it gives tertiary butanol. It follows SN1 reaction because it generates 3-degree carbocation. Now when this reaction was performed in 3 different types of solvent, acetic acid, methanol and water, we can see the rate of the reaction is extremely fast in water medium. Because from the dielectric constant value, it is clear that water is highly polar. So water can make a very strong hydrogen bond with the 3-degree carbocation, and it gives extra stability to the carbocation and which facilitates SN1 reaction. The solvent which is needed for SN2 reaction. In this example, ethanol is a substrate and Cl- is a nucleophile. And in SN2 reaction, leaving group leaves and nucleophile attacks happen together. So this is a transition state where you can see that leaving group is leaving and nucleophile is attacking, and finally we are getting the product. So in SN2 reaction, stability of carbocation is not an important factor like SN1 reaction. And here, rate of the reaction depends on both nucleophile and the substrate. That's why in SN2 reaction, carbocation and nucleophile both should be free. It should not be surrounded by the solvent molecules. If this nucleophile and substrate are free, then only the concerted process can take place smoothly. In this example, you can see that Cl- is a nucleophile, and if we use polar protic solvent like water, it makes hydrogen bond with the nucleophile. So here nucleophile is surrounded by protic solvents water molecules, and nucleophile is not free to attack carbocation, and it will affect the rate of SN2 reaction. Due to this reason, SN2 reaction cannot take place in polar protic solvent. Rather than it takes place in polar aprotic solvent like acetonitrile, DMF, acetone, because the polar aprotic solvent cannot make hydrogen bond with nucleophile, and nucleophile is free to attack carbocation, and concerted process takes place smoothly. So here also we have taken one example that definitely this reaction will proceed via SN2 reaction because it is forming 1° carbocation. When the same reaction we perform in ethanol and acetone, where ethanol is a polar protic solvent and acetone is a polar aprotic solvent, we can observe that in acetone the reaction is 500 times faster than the ethanol solvent. So again it proves that SN2 reaction favors in the polar aprotic solvent. I hope this video will be helpful to understand the importance of solvent in SN1 and SN2 reaction. And if you like this video, share it with your friends and subscribe my channel Chemistry Affinity. Thank you for watching it.